So here we are at acids and bases. So we want to first define acids and bases. Acids are things that are going to donate hydrogen ions or protons, and bases are going to accept those hydrogen ions or protons. Below we have a chemical reaction written out. We've got hydrochloric acid. It's going to be acting as an acid. It loses its proton, and we end up with a chloride ion. So these two are related to each other, and this we call the conjugate base. In a similar way, the water here is going to be the base because it's going to accept a proton and become a hydronium ion. So these two are related. And this is the conjugate acid. So on each side we have an acid and a base. Acid and a base. The acid is related to the conjugate base, and the base is related to the conjugate acid. And the only difference between the acid and the conjugate base is the absence or presence of that hydrogen. Now, water is a unique substance. It can act as an acid or base. We have an example above of it acting as a base. Let's see it in action as an acid. So we've got this compound here. And we've got water. And we're going to make okay, so here we've got a base. Let me get my other pen out. We've got a base, and we've got its conjugate acid. The difference here is only this proton. And then we have water, and it's donating the proton, so it's the acid this time. And over here is the conjugate base. All right, so that's kind of the terminology. Let's look at our curved arrow notation. The flow of electron density is going to be demonstrated with curved arrows. These are going to look a lot like the ones you used for resonance, but they're not. They indicate real change. Remember, resonance is not a real change. The true molecular electron density is kind of a mixture of all of the different forms, but it doesn't represent an actual change. Here we've got bonds being broken and bonds being made. So let's look at an example. We've got a base, and we've got a carboxylic acid here. And we're going to make water and conjugate acid. Okay, so let's put in some arrows. Our arrows are always going to begin on an electron source. So they'll either begin on the lone pairs or they'll begin on a bond. So they have to begin on electrons. So these electrons right here are going to come and they're going to be attracted to that proton because it's got a partial positive charge. It's attached to an oxygen. And the electrons that are in this bond are going to leave the bond and go live on just the oxygen. So we've transferred a proton. We have two arrows. Use two arrows and a base has to extract it. The proton does not just fall off. It has to have something come along and take it away. So let's look at some examples. In these two examples, we want to, we want to label the acid, the base, the conjugate acid, the conjugate base, and we want to draw reaction arrows. Okay, so these two compounds look very similar. This one has a proton that this one lacks. So this must be our acid, and this is our conjugate base. So that leaves our hydroxy, hydrogen, hydroxy, and our water, and we can see that this is a base. It's going to accept the proton, and that leaves this as our conjugate acid. Now let's look at our arrows. There's some electrons on this, and it's negatively charged, and so negative seeks positive. So these electrons are going to come up and attack that proton. The electrons that are forming the bond between the oxygen and the hydrogen are going to reside now only on the oxygen. So we should draw in our lone pairs. One thing I want you to note is that there's one negative sign on this side of the equation and there's one negative sign on this side. The negatives and positives don't disappear. You can use them to double check your work. Make sure you've got it right. Okay, so let's draw in our lone pairs. Okay, so we need to find our acids and our bases. So these two are similar, except that this one doesn't have a proton and this one does have a proton. So it must have gained a proton. So this must be our base. And this is our acid. Actually, the conjugate acid. Okay. This and this compound kind of go together, and this one has a proton and this one does not, so it has lost a proton or donated it, so this is our acid and this is our conjugate base. All right, so let's see what's happening here reaction-wise. Let me change pen colors. Remember, we're going to start the base of our arrow on a source of electrons, and we're going to have two arrows. So the proton is going to be transferred to this atom right here, so these electrons are going to attack a proton, and the electrons connecting the proton to the oxygen are going to go and live just on the oxygen. And I guess they're here. So this next one I'm going to show you. I'm going to ask you to pause the video and see if you could work this one out on your own. Okay, I'm assuming that you paused the video. I hope you did anyway. And we are supposed to just draw the mechanism here. Well, we've got some electrons over here and a negative charge. They're going to be attracted to that hydrogen. So these electrons here are going to go to capture that hydrogen, and these electrons are going to go to live on the oxygen.